Okay, let's finish this problem. Number 9 says, where is f increasing? So that means it's coming up, but it's concave down, which means that it's frowning at the same time. So let's see. Increases here and increases here. You notice this is also a point where your function is frowning simultaneously. So that would be letter F. Both of those are simultaneously occurring. This one says your function is decreasing, which means it has to be coming down, but it also has to be concave up. It has to be smiling at the same time. So A works. Notice decreasing, but part of the smile that we see. So A works. And I believe that's the only one that will work. Okay, do not pick H. H is a point of inflection, so it's neither concave up nor concave down. You have to commit. Okay, number 11 says, where is F both increasing and concave up? So it should be going up like this, and then it should be smiling at the same time. So C works. And that's the only one that will work. And then number 12 says, where is F constant? So you're looking for those points where you have zero slope. Your function's not moving up or moving down, so B should work. Let's see. If this were a point, this would work also. The same thing for this one, that would work. Here's another point. Notice your function's not moving up and not moving down. All of these y values are the same. So J should work as well. All right, so let me backtrack to some of these earlier problems. I need to go back and clean something up. Okay, let's start off with number 2. And for number 2, it says F has a local maximum. Now, I kind of lied to you because in order for something to be a maximum, it's not just that, and let me zoom in on this one just for a minute. It's not just that your y is higher than the points that are around it. It's higher than or equal to, right? That's how a maximum is defined. That it is higher than or equal to all of the points around it, which means there's a max right there. Because if I were to circle the region right around J, then all of these y values would be exactly the same. They would be equal to each other. Okay, so J could go here as a local maximum. All right, so I know that's a bit confusing to people. Let me show you what else would be a maximum. If this were a point right here, that would be a local maximum. This could be a local maximum as well, right? If that was labeled, but they're not. Okay, so let's move down to number 4, because I need to clean that up also. 4 says F has a local minimum. Okay, so what is a minimum? Let me give you that definition. A minimum is that it's lower than or equal to the points around it. Okay, let me zoom in so you can see that. Lower than or equal to the points that are around it. That's how we're defining a local minimum in this class. Okay, so if we look at that, we identified this one as a local minimum. But here's another one right here. So again, if you do that circle, this is equal to all the points that are around it. So J is considered to be a local minimum and a local maximum. So if you look at problem number 4 over here, I'm going to add J as in jump to that. All right, so that completes that particular graph.